Hi everyone. So first of all, I want to say thank you for coming to my talk. I know there are a lot of options to choose from, so I'm happy that you're here. Today I want to talk to you about web applications with React and GraphQL, and I'm really excited because this is my first Java specific conference, and I'm really excited to be here. So I'm Marion from Zurich, Switzerland, and I work for a company called Hasura. We are doing a GraphQL engine that allows you to create APIs very easily and very fast. It's open source, so feel free to check it out. In my free time, I like riding dirt bikes, so it's a nice balance to the other things that I'm doing and keeps my mind off all the other things. So I think this is enough about me. Let's talk about the agenda of this talk. So first of all, I want to ask who has been working with GraphQL already? Okay, few people. For the others, I will give an introduction to GraphQL and compare it to other kind of APIs, for example, REST. Then I will show you a demo on how you can build your GraphQL API. And then, this is the core of the presentation, I want to show you how you can access your GraphQL API from a React frontend. And based on this, we'll do a real-time demo. And demo of a real-time app that also uses these two technologies. Now let's get started. And first let's talk about an API call. So with traditional architectures like REST, an API call looks like this. So we specify an HTTP method, in this case get, and then we have a certain endpoint, in this case user, where we pass a parameter, in this case the user ID, that shows us which user we want to query. And then on the right, you can see the response that we'll get from the API. Now, let's say we want to get the address of a specific user, then the endpoint looks a little bit different, depending on your API, but we have to make two API calls. So one to user, and then one to the user's address. And while this is not too bad to have two API calls, it might get a little messy if you have suddenly a lot of API calls because, for example, your system is growing and you need to get a lot of data. So also, if you imagine a mobile app and you have this information on the UI, in this case, the username field comes from a different API call than the address. And this can lead to the fact that this data loads in a different point in time, which is not very nice to look at for the end user. Now let's say we talk to our API developer to help us out. And we just want to have one API call to get the user information and also the address. But maybe the API developer is on holidays, or he has more important things to do, or she, and then we have to wait until we get this endpoint, and until this point we have to live with the solution we had before. But what we want is we want an endpoint called user info, where we can pass the ID that gets us all the information in one query. Okay, now another thing, based on the device that we're using, we might want to display different chunks of data. So if we have a desktop, maybe we want to display more data than on the mobile because we have more space to display. Now, we go to our API developer again and we say, can you please help us out? Can you make an endpoint that can have optional parameters where we can define exactly which fields we want to have for this resource? And yeah, then this goes back and forth. So if this kind of workflow is separate for the front-end and the back-end developer, sometimes it can happen that the front-end developers are stuck because they have to wait for something from the back-end developers. Now let's say we can have something like this. So we have one endpoint slash GraphQL in this case, and it's the same endpoint for all the resources. We don't have to say user or address or anything. We have slash GraphQL, and it's always a post request. We don't need to worry about HTTP methods like delete, update, or anything. And we specify what we want to query. So we say here we want the user and ID name. from the user. And then later we might also need the address of the user, and then we can query this in the same query and get all the information at once. And this query language is called GraphQL. It looks like JSON a little bit, and it actually is. So what gets sent back as an HTTP response is JSON. And let me tell you a little bit more about GraphQL. So one of the key insights is that the API is modeled as a graph. So you can have multiple top-level nodes, and then it's like, I am sure you all know what a graph is. It's how it's modeled compared to relational databases. The other key insight is that the front-end developers or the API consumer, it can also be another service, controls what data they get. So me as a front-end developer, I say from the user, I want to have only the name and nothing else. And then this is what I will get. And this is a little bit different to the kind of traditional architecture, because the front-end developers are not anymore dependent on what resources or endpoints the backend developer will give them. Now let's look at the typical GraphQL query. So the blue thing, which is basically the query, is a keyword that is GraphQL specific. Query means we get something from the database. All the gray things are defined by my schema. So this query shows me that I have a table called user. The user has an ID and a name. Then there's another table called address that has a relationship to the user. And the table address has a field called street. This is what it tells me. But in your case, this might be different. So remember that the blue things are GraphQL specific. Gray things are dependent on your GraphQL schema. Now let's look how the GraphQL query looks underneath. So as I said, it's a POST request, and it's one endpoint. And there's no content type for GraphQL. So it's JSON, content type is JSON. And we just pass the query in the body as a string. Then the GraphQL server will parse this string, do whatever it needs to do, and then sends back the data result again as JSON. And you can find it when it comes back. The result is always in the data key of the JSON. So this is how it works underneath. And now we've seen how we can get data from the API and make queries. But at some point we want to write to the API. We want to insert new things. We want to update objects in our database. So before GraphQL, this is very typical. We have post, put, delete, and patch, how we can change things in the database. Then we say which method we want, in this case post, the endpoint, and we send the data and get a response. In GraphQL, as I said, always post. And what we are doing, we're using again a keyword. In this case, it's not query, it's mutation. And mutation tells us we want to change something in the database, but it doesn't tell us what. So just from mutation, we don't know if we want to insert, update, or delete something. So we have methods in our API, in this case add to do, that we define. So we're responsible to have good names so that front-end developers know what we are doing here. So it's very simple. It's called add to do. And then we have to pass the data that we want to add. And because it's cumbersome to have this whole JSON in the brackets of the function, we just use variables. So we say here, the new to-do will be, it's the variable, and then we pass the query variable down here at the bottom. Yes, and a mutation of GraphQL always returns something, but it doesn't have to be the ID, like in the example before. It can be anything. I can also return the to-do or anything else that is a field of this table. Now the third thing is, let's talk about real-time APIs. So this requirement has come up more often, and for a lot of mobile apps and also web apps, it's necessary that we have real-time updates. For example, let's say a food ordering app. We want to get updates when, for example, the payment has been approved or when the food has been delivered. So before GraphQL, there are two options to have these real-time updates. So one of them is polling, which means that the client makes repeated requests to the server, like every second, to get the most recent state of the data, and then updates the UI. The problem here is this is not very clean, because a lot of these requests don't have to be made if the data doesn't change every second. And this can lead to the API getting slower, because maybe we have to query something else, and then there's like traffic and it gets slower. The other option is WebSocket. So you can totally build your WebSocket that pushes the data to the client. And this works, but it's very hard to implement. It's easy to implement in a basic way, but it's hard that it's reliable and that you can be sure that all the updates get sent to the client. So with GraphQL, you can use subscriptions. Subscriptions are when a client can subscribe, for example, in this case, to the order with this specific ID. And then when something changes, in this case paid and dispatched, when something changes, an event gets sent from the server to the client. And then the client can update in real time without having to reload the browser or the app. It also works with WebSockets, as you can see here, WS. But you don't need to implement the WebSocket by yourself. So there's a lot of community tools that you can use. In the case of GraphQL, most people use Apollo. Maybe you've heard of it. So Apollo is a service that helps you connecting your GraphQL API to any kind of JavaScript framework, and I will show you later how you can do this. Let's talk about documentation. So before GraphQL and with the usual APIs, writing documentation is separate from actually implementing the API. So after implementing or during implementing, developers have to make an effort to actually also write the documentation. So the usual workflow is the API developer builds an API. Then the API developer writes documentation, and I put this in red because maybe they don't. Or, yeah, you know, there's a lot of things to do, and documentation is not always at the top of the priority list for everyone. And depending on how nice they are or how much time they have, they will maybe share a Google Docs or use some other tool like Postman or Swagger. Then you read the documentation, which I also put in red because who has the time to go through a whole document and read everything, right? Based on this, if you read it, you will start integrating the API and try to use. And many times you will find that there's documentation missing because maybe somebody fixed something yesterday but didn't update the documentation, or it's out of date, or it's simply wrong. So with GraphQL, implementing the API goes hand in hand with writing the documentation, because actually you don't need to write the documentation. So why do I say this? When you create your tables and relationships, the GraphQL schema, or the database schema, gets created automatically for you in the background by the GraphQL API. And this schema can act as documentation. You can see here an example on the right-hand side. So type user, and you can see what fields that type user has. Okay, but how to access this information as a front-end developer? There's a thing called introspection API that all GraphQL APIs have, which means that you can inspect the types. In this case, we say we want to inspect the type to-dos, we want its name, and we want all the names of the fields. And on the right, you can see what we'll get. It's exactly this. So if a front-end developer or any other consumer of an API is not sure what fields they can query, they can just look it up with an introspection API. They don't need to talk to any developers. They don't need to wait for an endpoint. And the workflow can be more efficient. Okay, there are some challenges that come with adding GraphQL to your project. One of them is you don't have full control what will be queried by other developers. So you don't know if they make n+1 queries. For example, if you have a huge database and somebody queries all users and all addresses, can be a problem. and slow everything down or even crash. So these challenges are, I mean, they can be solved, but it's something that we have to think about actively to prevent these things from happening. The other thing is access control and authorization, which means, for example, the food ordering app again, I need to make sure that I can only access my own orders, right, and not everybody else's as well. So these things need to be made sure. And finally, when the people of Facebook created GraphQL, they meant this to be used for a monolith. So very large applications, all the types are in one place and can be used. And relationships can be created, everything is in one place. But a lot of architectures now move towards cloud native, which means it's by default more use of microservices, and it's serverless. So these microservices need to be able to talk to each other somehow, and they need to share types, because if I have a microservice and you have a microservice, I need to get some data from your microservice too, or I need to somehow bring them together. So this is also something that we have to think about, and I will come back to this later in the talk. Okay, enough talk. We'll see how we can create our own GraphQL API. Okay, so you can implement your own GraphQL server if you have the time, but you don't have to. You can use any kind of service, for example, Hasura. Here you can see all the, so Hasura is a special kind of GraphQL API. It runs in a Docker container. So you can deploy it to any kind of cloud provider that runs Docker, which is every cloud provider. And you can also run it locally on your machine. If you're worried about data security, for example, and you can't have data in the cloud, you just run it locally in a Docker container. Okay, so we'll get started with Heroku because it's the easiest and the fastest for a demo. Okay, let's say I already used this. Okay. And I deploy the app. So this takes like 15 seconds. And in the meantime, so Hasura has Postgres running underneath. When we deploy this now, a Postgres instance gets created, and you don't have to worry about this, but maybe it's interesting to know. So what happens when you make a query in GraphQL is this query gets translated to SQL, run against the Postgres database, and then sent back directly to the client as a JSON. This may sound a little bit a long way to go back, but it's the fastest GraphQL engine on the internet at the moment, and the reason why it's because it's implemented with Haskell. I'm sure you've all heard of Haskell or know it, so it's meant to make things fast. Okay, so now the app is deployed. We can view the app, and the first thing we see is graphical when it loads, which is, it's not specific to Hasura. You can use this for any kind of GraphQL API. This is how it looks like. So here we can see that one endpoint that we'll use for all the clients that we have. As we said, it's a post request. Here we have all the request headers. Maybe later we'll have authentication, so we might send an auth token here. And this is our playground where we can make queries and see how things work. So let's just add a test table. Let's say name, text, and we need a primary key. This doesn't really matter, it's just a test. So now we have a test table, and now we could make queries here. And obviously there's nothing in the database, so nothing comes back. But this is how it works. Usually people use this tool to try things out, and then you can copy, if a query is working, you can copy paste it and use it from your front-end application. Okay, so now I have here, to make it larger, a huge file with create statements and also a lot of data. Maybe I can make this. A lot of data that we want to populate our database with. So I want to import this here because I don't care for creating all these tables by myself. So now I need to find the link to the Postgres instance of my project, which is here, and then I can do PSQL, which is a tool provided by Postgres, then my Postgres database, and the file is called data SQL. So I want to import all this data in our project. Let's start this. Okay. Now when we go back and we go to data, we can see here track. So this means the data is now in Postgres, but it's not yet exposed over the GraphQL API. So we say track all. This takes a while because it's a lot of tables to create for Postgres. Perfect. And now there we have some foreign key relations that we also want to track because we want to have also the relationships. Okay. Now I can go back here and I can make a query. And I don't have to write it, I have here the Explorer. And let's just say we want to have the count of albums. And this is a query, so it comes back, and now we have 39 albums. But because we were talking about real-time before, we can change this into a subscription, and then we can see in real time how these albums, so it's still running here, get added to our API. And I did this a little bit quick because, you know, there's not unlimited albums, so I have to go back a little bit and explain. So we imported the data in our Postgres database, but Hasura doesn't expose anything to your GraphQL API if you don't specifically say so. So you can also have data just in Postgres without ever exposing it. Only if we say track, then it will be exposed over the GraphQL API. And now we have, I think this is all the albums that we have. Okay, and here I also want to show you, we've been talking about access control before. So quickly, I just want to show you how this looks like. So Hasura has a role-based permission system, which means, so by default we have admin, and admin can do anything because I need to be able to create tables and manipulate data. But then maybe later I want to have a user role, and I say they should not be allowed to insert, update, or delete anything, but they should be able to read from the database. And the most common thing to do is saying, for example, the ID that they pass has to be equal to X Hasura user ID. So this is just the header that you can pass, and then what is sent in the header will be compared to what is in the database, and this is how you can validate if this is actually which user can access which data. And then I can also say, okay, the user can access this data, but only the title and not the ID or the artist ID. So this is about access control, very briefly. So let's go back to the presentation. Okay, now let's do something a little bit more exciting. Let's say we build Twitter, and somebody makes tweets with bad words. So we cannot have this on Twitter, right? And we can also not have it on our own application. So what we want to do is a tweet comes in, and then we want to we check, and then we want to sanitize the text, and then return a sanitized version of this tweet that we can show. This is how the structure will look like. So let's say somebody types some potentially bad content. Then we'll do a GraphQL mutation, which means we add this content as it is bad into the database. Then we trigger a serverless function that goes through this content and checks if there are bad words in it, updates the tweet with a sanitized version with, again, a GraphQL mutation, and then all the UI components that subscribe, we've seen before the subscription, that subscribe to this tweet will get updated when the sanitized version is available. So now this was a little bit fast. So let's see how this works. I have to close these. Okay. So I have here an empty database schema, but I already deployed this dangerous tweets. So I create a table called tweets. It has an ID, which is UUID, and we generate this randomly. Then tweet has a raw version, which is text, and a sanitized version, which is also text, which is nullable in the beginning. Because we said before, the first thing that will be inserted in the database is the raw version with the bad words. And only later will we update the tweet with the sanitized version. So we have to make it nullable in the beginning. Now, we select the primary key, which is ID, and we add the table. Okay, this works. Now, before we actually go about the business logic, we can close this. I will show you the React application that makes the UI for this tweet. So as I said before, we need to somehow find a way to connect our GraphQL API to our React frontend in this case. So in the index.js, what we need to do is we import Apollo client. And I said this briefly before, Apollo client is meant to do exactly this, so that you can use your GraphQL queries and mutations as easily as possible from your front end. And you don't need to care about any kind of configuration after you did it once. So we import Apollo client. This is not so important, and WebSocket link. So now we create an Apollo client. We pass the WebSocket link, and this link is exactly the endpoint that we have here. And we define this once. Yes, and here, this is important. In React, all the child components usually live inside the app component. So by wrapping the app component inside Apollo, we make sure that we can use GraphQL from all our child components that we will create later. So we don't need to worry about this anymore. Okay, now we have one component called dangerously tweet. We import GQL from GraphQL tag and use mutation because we want to insert, our first step is to insert a raw tweet in our database. Now, this mutation is completely GraphQL, and this is exactly what Apollo is doing. By using Apollo, we can try out this mutation in our UI. When we see it works, we can just copy paste it in our front end and it will work as well. As you can see, we pass this in this kind of weird strings that then later the server will parse. Okay, so this is the mutation that we defined. We call it add tweet. Now, when we start this function, we execute this mutation that we just defined earlier, add tweet. And with Apollo, we have access to data loading and error. So let's talk about the second two first. So loading is what will display when it's not ready, when it's still loading. So we can display a loading spinner or just say loading like here. When there's an error, we will show the error. And for now, when we added a tweet, we just say dispatched. This is all we do for now. So let's see if this works. So the UI is not beautiful. Okay, so I need to use, okay, now I can just say hi Jfokus. Dangerously tweet is said dispatch, so, but we want to make sure if this works. And yes, okay, so this was inserted in the database. So this is working, but it's useless because still we have not sanitized anything. Now, let's focus on the sanitizing part. I have here, and this is now loading because I haven't used it for too long. It's a serverless function that I created on Glitch that will sanitize my tweets. It's a simple Express server, and we use a library called bad words because I cannot think of all the bad words to filter. And then we have the raw tweet that we pass. we use the function clean that comes also from this library bad words to clean the raw tweet and store it in a variable called sanitize. And this is the most interesting part here. So we connect here to the endpoint, the same endpoint here, and we update the tweet. We don't delete the raw version of the tweet, but we add the sanitized field for this object after we sanitized it, and pass these two variables. So obviously we have to define by the ID which tweet we want to change, and then pass the sanitized version. So now I have to get the URL. Okay, and what I'm doing now is adding an event trigger. So because all the database operations that you can do are sometimes not enough, so you need an eventing system for exactly things like this. So we create an event trigger. We call it sanitize. And we're saying on the table tweets, when we insert a tweet, then we want to trigger this serverless function. So every time a new tweet gets added that just has the raw version, we trigger this serverless function. So we create the event trigger. And now let's just see if this works on the UI here. We go to tweets. Okay, now I have to think of a bad word that I can use because of code of conduct. Okay, so I think I can use go to hell. Save. And now let's see if this works. Yes, it works. Okay, so I have here the raw tweet, and then here the sanitized version, which just replaces my bad word with nice stars. Okay, it works, but now we want to use this for our React app as well. And now we have to change something here. So this dispatched is not enough anymore. So what we want to do, if there's loading and error, still the same thing. But if there's data, we now want to render the component called tweet status. And to this component, we passed the tweet that we inserted with the ID here in the end. Now this component looks a little bit different. So again, we need to import GraphQL, but now we use subscriptions, because this component doesn't need to change anything in the database, but it has to subscribe to updates. So this component needs to know if there's a sanitized version available, and if yes, then display the sanitized tweet. And this is exactly what we're doing in the subscription. We say the ID that we got passed from the dangerously tweet component before, and we subscribe to this tweet and say we want to subscribe also to the sanitized version so that we get updates. Now, as before, we use subscription and pass the one that we defined earlier here. Loading and error is still the same as before, but now this is the interesting part. So what we're saying here, we say if we don't have data, and by data we mean something typed into the field, if we don't have data, or if we don't have the sanitized field, then we can't display the raw tweet. Then we just display a GIF that says we're still cleaning here. Maybe we have lost the connection or something, so it was just say we're cleaning. If we have data, and if the data has a sanitized version of the tweet, then we show the sanitized version of the tweet, and we have another GIF that shows we are innocent now. Okay, so let's see if this works. Flag is hell nice. So now we're cleaning, and now we're innocent, and the sanitized tweet you can see on the top. So this is working. Demagogues have been nice to me. Okay, so you've seen the real-time, this was now a real-time app to show you how you can subscribe to certain tables or fields and not having to reload and get instant updates on your UI. Now, we've talked about other challenges that we have with GraphQL. And one of them was that we have different microservices and we somehow need or want to bring them together. And so I'm talking about a new feature that I hope will go live next week that we introduce. So what you can already do with Hasura is stitching schemas together. This is not new. You can, I have my own API, and then let's say I have another GraphQL API, and I could just stitch them together, and then can use both of them, can query both of them from my API. So this is a nice way of having people work in teams on microservices, but then the people who have to access the data can still do this from one central point. But we said before that we don't want to make several API requests for if we actually only need one chunk of data. And if I have different microservices, I might have to do this. So we're introducing a new feature called remote joins, where you can have relationships across schema and then have one query to query several resources. In this example, let's say we have a Postgres database and we have an integration with Stripe. Stripe is a payment service that is often used if you have something like a payment service on your app. And now let's say we have a customer table in our API that has an ID and an email. And now what I can do is create a relationship to Stripe and also for the same customer get the data from Stripe. This way I don't have to go to make an API call to my API, get the Stripe customer ID and have to make another request to Stripe. So I can do this in one query. Another thing that will for sure go live next week is a kind of Flux-style one-way data flow that we call actions. So until now, you can do mutations and save something in the database, and then based on this, as we've seen before, trigger something and then update what you've just created. But what we're introducing now is that you can trigger serverless functions, business logic, inside the mutation. So let's say we have a food ordering app again, and I create a new order on my phone. Then this goes to the Realtime GraphQL API and starts a mutation that is called maybe create order. Then this event goes to the event store, and through the eventing system, a serverless function gets triggered called payment processing. If this was successful, it goes back to the event queue or event store, again through the event system, and the next serverless function gets triggered called restaurant approval. And then the same with delivery assignment, like how many ever steps you need for your app. And what you can do is either go through the whole process, then in the end store the final order object in your database, or you can have real-time updates after every step that you do, which is what you will want to have if you have a food ordering app, because I want to know, for example, when the driver left and will arrive at my house. So this is kind of an easier workflow that requires less API calls and less steps. And regarding subscriptions, we talked about real-time before. So we need to have reliable subscriptions that we can be sure will send events to the client. So with Hasura, you can have 1 million concurrent subscriptions. If that is not enough, you can just create another Hasura instance, stitch them together, and then you have 2 million. And these will make sure that all your clients that subscribe to certain tables will get updated. So with this, I think that's all for now. I have stickers if you're interested. If you have questions, please come and ask. And if you want to get started with GraphQL, I have here a QR code to tutorials. So first of all, introduction to GraphQL, but also connecting it to any kinds of front-end framework that you're using. So thank you very much.